transfer function that takes that exterior reading and creates a reading for you to pick up. Now, it might not be a straight line. It might be a sort of curved line. It might be doesn't have to be a straight line sort of going up. But basically, you give a certain input to it, and you'll get a certain voltage coming out. Now, as I say, we don't deal with making that. That would be up to the manufacturers to do. You might give them, if you're commissioning something like this, you might say, look, I want an output voltage 0 to 5 volts, and I want it to read, say, light power going from 1,000 lux up to 2,000 lux. And you sort of give that specification. And knowing that specification, they'll build you this sensor, if you like, or drag one off the shelf that does it already. They might do it the other way around, saying that, look, if you give me a voltage, I'll set that, I'll sort of tell you what reading should have given you that in the first place from it. So as I say, it might be a linear one, a straight line, S equals A plus BX is a straight line. Not many sensors really produce that. It might be that it takes multiple values as well, like a humidity sensor. You get relative humidity and temperature. You might have many sensors feeding into a single output, and eventually sort of reaching some sort of saturation point. It's just so we're aware of what we're dealing with in the background. However, one of the things that we do need to be aware of with a sensor is these three sort of aspects: the resolution of it, which tells you what's the sort of increment that I'm working with here to it. If I said I can measure distance to the nearest kilometre, how far am I from the corner of this room? I'm 0 kilometres from it. How far am I from the centre of Manchester? Well, 1 kilometre. I mean, that's not a very nice, it's too big a resolution. On the other hand, if I said, look, the resolution is in millimetres, how far am I from the sort of corner of the room? Oh, you are 10,260 millimetres from it. You might decide that's too fine a resolution to sort of measure it. What a resolution does is just describe the increment when you receive a stimulus from that sort of sensor. How big a jump does it do between one? And when you get one of these, they'll normally let you know what the resolution is. The accuracy is just how close that is to the true value. So if I use my sensor to measure from here to the back row there, and the sensor says, yeah, it's 5.6 metres to the back, and it's actually something like 20 metres, it's not a very accurate sensor to do it. If it was 5.68, then I'd be fairly happy with that to get it. And the repeatability is just like, if I use that sensor once, measure it, and use it again and measure it, is it going to be consistent in giving me that same thing over and over again? Now, when you buy a sensor, and again, if you sort of nip over to the fidget site, say, I should have brought this up before. We use these fidgets, and if I pick up a particular, this particular, just fairly at random there, this distance sensor for it, that measures distance, but I might want to know, well, what specification has that got? How accurate is it, for one thing? What sort of voltage does it generate? What sort of voltage does it need? I'm looking for the thing that tells me its accuracy, really. One of the things... No, maybe under the user guide. I can't find it just sort of offhand, but one of the aspects of this would be how much it can actually measure. That phone's going off like crazy as people press the button for it. So you can find your actual how good that sensor is, typically off the sort of the manufacturer's homepage or your engineer's specification for it. But in terms of the type of sensors that there are, this is a bit that I'm not sort of too interested in really. The actual whether or not they're using resistance to measure it for light and force or magnetism or inductance. These are just sort of the different ways of picking up the actual sort of sensor information. Thermoelectric, pyroelectric, sound sort of levels to electrochemical ones. You can have a look at that, as I say, that sort of sample vendor. But we do have lots of sensors already built into certain devices. Now, as I say, typically something like a phone will have a pile of these things built into it. An Android phone, you can use it for measuring heart rate, the gyroscope for deciding which way up it is, the accelerometer, pressure things, fingerprint sensors, some of which can be found using, say, a toolkit. You'll be surprised at how many sensors you can use on this. There's a physics toolkit somewhere. Again, just sort of bear with me. For example, here we've got a physics toolkit built in that can measure, in this case it's measuring G-force. And there, as it's vibrating, thank you. I need to turn the sound off. They're the sorts of things that are sort of happening to it. Now, all those are detectable by Android code. For example, you could just sort of dig into that and pick them out. I'll plug it into a speaker that isn't connected, just to shut it up. So where you're getting sensors from depends on yourself, what you're willing to put together for these. Either something that's, if you're doing a phone app, it might be built directly to the phone. It may be that you've got like the fidget sort of type one, or this sort of idea. Where is it? These sorts of things where you can buy a kit of sensors ready to plug in, say, a Raspberry Pi. So there we've got a sort of collection of sensors with a breadboard. I've shown some of these before. There we've got a sort of a big kit ready with breadboard for about £37. And you just get a Raspberry Pi to control it. Alright, so I'm sort of going a bit mad with that button there, can you? Now, using those two together, you would build your own node then. You'd build a node out of that collection of sensors and some sort of processor to make it together with. Now that's essentially what's in one of these. Essentially in there, it's not a Raspberry Pi, but it's some processor that's in there, connected to a pile of sensors and actuators, and then put in a nice little white box that you can just attach to your radiator. And that's what you start to make your money on. So if you're sort of into sort of building your own Internet of Things, we are going to be building conceptual models, but what you need next really is some sort of product design person to take those sensors and actuators and somehow get them into a nice little white box that goes on a radiator on your wall or whatever, something like that for it. Actuators then, as I say, might be just the general sort of motors, some of which sort of electrically generated. There might be pneumatic ones. Typically, these are the sorts of things that you're normally doing with an actuator. Something to display to the outside world, perhaps moving objects around, lighting them up in some way for it. The sensors broadcasting out a range of signals. So you've got these digital signals coming out, and again, they're the things that we're picking up on in the labs. But we've got to be careful about noise to these. You might have seen in the labs, I was often saying, work this with a slider sensor or a rotator sensor, because if you use one of the button sensors where you put your thumb on it and press it, it bounces about all over the place, or a distance sensor, and it becomes a bit hard to actually get it sort of programmed correctly. And also, you may get noise creeping in that causes side effects. For example, this BBC news article here caused a bit of a problem last year. You can find it. Where some fancy mower going along started causing some effects with triggering sensors. They had sensors for detecting the northern lights. Now the northern lights, they are basically electrical charge signals going on in the atmosphere. They've got these sensors all about the Arctic Circle, sort of north or whatever, detecting this. And the lawnmower triggered a lot of these sorts of things off because the sensors were a bit oversensitive to it. I get the same thing in my car. The car alarm goes off whenever an unsuppressed motorbike goes by when it's parked outside my house. It's revving at the right sort of level. The electrical signals given out triggers the sort of car alarms.